Okay, so in this lecture on polynomials, first of all, I would like to tell you few points that once you watch all the lectures of polynomials and quadratic equations, only after that you go and attempt questions from any source, okay? Any source or study package that you may have of IIT Foundation. Even if you are in 10th class, you can attempt JEE main questions of previous years. After watching all the lectures of polynomials as well as quadratic equations, because some of the topics will be covered in polynomials and rest of the topics will be covered in quadratic equations. So you have to watch both the playlists before attempting any question or before feeling confident. Then you will feel confident about every question that you will have. Second thing that I left a small topic about sum of coefficients. Sum of coefficients. Okay, let us say you have got a polynomial f of x equal to a n x raised to power n plus a n minus 1 x raised to power n minus 1 plus a n minus 2 x raised to power n minus 2 plus and so on till a1 x plus a naught. Now if you want to find sum of coefficients, right, that is you want to find a1 plus a naught plus a1 plus a2 plus up to an, this is the sum of coefficients. Then what you need to do is you simply need to replace x with 1. F of 1 will give you the required sum of coefficients, because when you replace x with 1, this term will become 1, this will become 1, this will become 1, and you will get the required sum of coefficients. Now if a polynomial is given in the question, it can be any polynomial, okay, it is a polynomial, right? Question will mention that this is a polynomial and you need to find the sum of coefficients. So what you will do in that question is you will simply replace x with 1 and you will get your answer directly. Second question on sum of coefficients can be asked, find sum of coefficients of even powers of x, or similarly another question can be asked about sum of coefficients of odd powers of x, right? Now consider this general polynomial once again. Consider this. When you do f of 1, you got this sum of coefficients. Now you do f of minus 1. What will you get? When you do f of minus 1, you replace x with minus 1, right? Let us say you replace this x with minus 1. Now depending on n being odd or even, if n is even, then it will not change the sign of this term, right? But if n is odd, then this term will change its sign, right? So if I do f of minus 1, what will happen is every term that has an odd power will become negative. So let us say, for example, n is negative, okay? N is negative. For a moment, consider n is negative. Then what kind of terms will you have in f of minus 1? You will have first term like this. Then if n is odd, consider n is odd, then this term will become negative. Then n minus 1 is even, because n is odd, so n minus 1 is even. Then this term will remain with the same sign. Similarly, next term will change its sign because n minus 2 again will be odd, right? And then so on. I hope you got the idea. When I put x equal to minus 1 in the polynomial, then what will happen is every term that has got odd power of x will change its sign, okay? Now if I add these two, f of 1 and f of negative 1, what will I have? See, every term, right, will every term that has got odd powers of x, right, will get cancelled. Now if you add these two, this term will get cancelled, this term will get cancelled, and only the coefficients with even powers of x will be there in this result, but these will be 2 each. Like if I'll have to add this and this, so twice of sum of even powers of x, even powers of x, right? It is not necessary that n is odd, n may be even. In that case n minus 1 will become odd, right? But we need to find the sum of coefficients of even powers of x. So it is sufficient that once you put x equal to 1, then you put x equal to minus 1. What will happen is, when you put x equal to 1, you will get sum of all the coefficients. When you put x equal to negative 1, you will get sum of you will get sum of coefficients with alternating positive negative signs, right? And the terms with odd powers of x will change their signs. When you add f1 and f of minus 1, every term will get cancelled that had got odd powers of x, right? And you will get these coefficients, the coefficients of even powers of x, 2 each. Okay, so now to get sum of even powers of x, I will divide both sides by 2. So the required sum will be equal to f of 1 plus f of minus 1 divided by 2. Now consider this. If you want to find sum of odd powers, sum of coefficients of odd powers of x, then you simply need to subtract. So you simply need to do this subtraction. You will subtract f of minus 1 from f of 1, right? In this case, the coefficients of even powers of x will get cancelled, and now you have to divide it by 2 to get the required sum of coefficients of of odd powers of x, right? So to calculate the sum of even powers of x, you just need to do f of 1 plus f of minus 1 divided by 2, and to calculate the sum of odd powers of x, you have to do f of 1 minus f of minus 1 by 2, right? I have explained you the logic that when you put x equal to 1, you get the sum of coefficients. When you put x equal to minus 1, only those terms will change their signs where the powers are odd, right? I hope you have understood this. Okay, now another topic that is left in polynomials is division algorithm. Division algorithm. I hope you have done the real numbers chapter before this, and if you have done the real numbers chapter, we talked about something like dividend. Dividend is equal to divisor into quotient plus remainder, and we said that this remainder is always lesser than this divisor, right? This was Euclid's division algorithm, right? In case of polynomials also, this algorithm works. Okay, when you divide, let us say you have got two polynomials px and gx. Okay, this, let it be the dividend, and let it be the divisor. Now it is divisor, so it should be non-zero. When you divide px by this divisor g of x, you will get certain quotient, let us say q of x, and certain remainder r of x, where the degree of this remainder, will always be lesser than degree of the divisor, right? Degree of the divisor. So this is Euclid's division algorithm that holds true in case of polynomials. The only difference is, in case of real numbers, we said that remainder is lesser than the divisor. In this case, we said that degree of remainder is lesser than the degree of divisor. And if p of x is divisible by g of x, the remainder will obviously be 0. So the remainder will be 0 if p of x is divisible by g of x. Otherwise, the degree of remainder will be lesser than the degree of divisor. So we already know how to divide two polynomials, right? So when we do the division, we stop at the step when the remainder is of lesser degree than the divisor. Either the remainder becomes 0 or it becomes of the lesser degree than the divisor. Let me take a very simple question that you have done in junior classes also, and then I'll take 2-3 questions that will give you the glimpse of what this chapter is, or how useful this method is. Okay, so let me clear the board. I'm taking this very simple question: divide this polynomial f of x by this polynomial g of x and find quotient and remainder, right? This is just to give you the revision of what you have learned about division of polynomials. Then we will move to some difficult questions to understand this chapter in depth. Okay, so to divide this f of x, f 5x square plus 9x minus 1, it is to be divided by 2x minus 1. Now to divide this polynomial, we just focus our attention on the first term here and first term of the divisor, and think how to create this term from this term. I have to multiply this term with certain polynomial to obtain this term. So what do I multiply this term with to get this term? Obviously 7x square. If I multiply this with 7x square, I will get 14x cubed, and the next term I will get is minus 7x square. After that you just subtract, right? This term will get cancelled here, and 2x square plus 9x minus 1. Now you focus your attention on this term and this term. What do I multiply this term with to obtain 2x square? Obviously plus x. So it will become 2x square minus x. Now I subtract. So this term will get cancelled and this will become 10x minus 1. Now what do I multiply this 2x with to get 10x? Obviously 5. So I'll multiply it with 5. So this will give me 10x minus 5. Now the subtraction part. So this will get cancelled and 5 minus 1, 4 will be the remainder. After that you don't have to do anything, because now you have got a remainder which is of lesser degree than this. What is the degree of this divisor here? It is 1, right? It is a linear polynomial. The divisor is a linear polynomial. So the remainder I was expecting was of lesser degree, that is a constant, right? 4 is a constant. Hence I can say that this is the division is complete. Now what I can say about it, that this polynomial here can be written as 14x cubed minus 5x square plus 9x minus 1 can be written as 7x square plus x plus 5 into 2x minus 1 plus the remainder, that is 4. So this is the way we will write this polynomial. Okay, so this was Euclid's division algorithm for you. Now let me do 2-3 questions so that you understand this chapter in depth. Okay, let me write the next question. Find the remainder when x raised to power 100 is divided by a quadratic polynomial, that is x square minus 3x plus 2. Okay, this is a 100th degree polynomial. I have to divide it with this quadratic polynomial and find the remainder. So what kind of remainder are we expecting? We are expecting a linear remainder. We are expecting a remainder of lesser degree than 2, right? So it can be either linear or a constant, right? And constant including 0, right? It can be 0 also if it completely divides x raised to power 100. So if I write x raised to power 100 using the Euclid's division algorithm, this is the divisor. So let me write the divisor like this. I'll get a quotient. So let me write the quotient as q of x, plus then I'll get a remainder. I need to find a remainder, right? Let me consider the remainder to be ax plus b. Why have I considered it as ax plus b and not anything else? I have considered it of the linear form, right? Ax plus b, but I haven't said anything about a and b. Okay, so it can be linear, or if b is 0, right? If b is 0, and let us say if a is 0, then the remainder will become b, it will become constant. If a and b both are 0, then the remainder can be 0. So I have taken ax plus b in such a way that the remainder that I am expecting can be linear, constant, or 0, anything, right? I have not said anything about, I have not put any restrictions on a and b. Now, to solve these kind of questions, first thing that you need to do is, if you can factorize this term, you factorize it. This is simple factorization. You can do it like this: x minus 1, x minus 2, q of x plus ax plus b, and this is x raised to power 100. Now see, if I divide this polynomial x raised to power 100, or what I do, if I put x equal to 1 on both sides, what will happen is this will become 1 raised to power 100, which is nothing but 1. This term will become 0, because when I put x equal to 1, this bracket becomes 0, making this entire term 0, right? And what will be this term then? This will be nothing but a plus b. Okay, when I put x equal to 2, the left hand side will become 2 raised to power 100. Again, this term will be 0, because now this bracket will become 0 when I put x equal to 2. So, and this term will be 2a plus b now. Okay, why am I doing this? Why am I putting x equal to 1 or x equal to 2? Because I saw this opportunity here to make it 0, right? I put x equal to 1, then this term became 0. I put x equal to 2, this term became 0. So I saw this opportunity to get these two equations. Now out of these two equations, 1 and 2, I can easily find values of a and b. That is what my aim is, because I need to find the remainder. So when I do this subtraction, second minus 1, b will get cancelled, 2a minus a will give me a, and on the left hand side I'll get 2 raised to power 100 minus 1, because 1 raised to power 100 is 1. Okay, if now that I have got a, I can put value of a, let us say, in first equation and get the value of b. When I put a equal to 2 raised to power 100 minus 1 here, what will be the value of b? So b will be equal to, when I take this on the left hand side, this will be 2 minus 2 raised to power 100. So b is equal to 2 minus 2 raised to power 100. Okay, so what is the remainder? What is the final answer? Remainder is ax plus b. Okay, so the remainder, final remainder, is 2 raised to power 100 minus 1 into x plus b, that is 2 minus 2 raised to power 100. So this is the required remainder. Okay, so let me take one more question. When polynomial f of x is divided by x minus 1 and x minus 2, it leaves remainders 5 and 7 respectively. What will be the remainder? What will be the remainder when f of x is divided by x minus 1 into x minus 2, right? X minus 1 into x minus 2. Now again, I will use Euclid's division algorithm and write f of x equal to this divisor here, x minus 1 into x minus 2, into some quotient q of x, plus the remainder. Now I will write the remainder, because this is a quadratic, right? This divisor is a quadratic polynomial. So I will write my remainder in this form, ax plus b. Okay, I have already explained it in the previous question. Now when f of x is divided by x minus 1, it leaves remainder 5. Okay, what does it mean? It means, let us say, I write this using Euclid's division algorithm, that f of x, when it is divided by x minus 1, it will leave some quotient, and the remainder it says is 5. Okay, now look at this I have used simple Euclid's division algorithm. Now if I put f equal to 1, x equal to 1 on both sides, this term here will become 0, so f of 1 is equal to 5. So basically the statement that when f of x is divided by x minus 1, it leaves remainder 5 means f of 1 is equal to 5. Similarly, I can say f of 2 is equal to 7. Right? Once I know this much, now let us focus on this. F of 1 is equal to, when I put x equal to 1 here, this bracket will become 0, hence this entire term will become 0. So f of 1 will be equal to 0 plus a plus b, a plus b. And what is it equal to? F of 1 is equal to 5. So this gives me my first equation. Now let us talk about f of 2. When I put x equal to 2 here, now this bracket will become 0 and this entire term will become 0. So this will become 2a plus b, 2a plus b, and it is equal to, what is f of 2? F of 2 is 7. So this is equal to 7 and it is my equation number 2, because I want to find a and b, right? I just want to find the remainder, so I have to find a and b, and I'll put that value of a and b in this to find my remainder. Now simple manipulation, I'll subtract first equation from second equation and it will give me, b will get cancelled, 2a minus a is a and 7 minus 5 is 2. So I've got value of a, I'll put it in equation number 1. So b is equal to 3, hence the remainder is equal to, remainder is ax plus b, so I'll put value of a and b here. So the remainder is 2x plus 3. This is the answer, right? I hope these type of questions you can easily attempt, right?